In this video, we're going to talk about Unicode and Python 2 and Python 3. Unicode is a standard text representation. ASCII can only represent 128 characters, and there are many languages in the world that have a lot more than 28 characters in aggregate, so we need to have Unicode so we can represent all of these different characters we'll see flying around the internet. There's a couple really good references for this. We had Working with Unicode in Python from O'Reilly. We also have Unicode in Python, completely demystified. We're going to look at Unicode with reference to Python 2 and Python 3. The Python community is moving very slowly from Python 2 to Python 3, and at this point we're in a transition period. So let's start with Python 2. In Python 2, strings may be two types, string and Unicode, str and Unicode. Type str is ASCII, or bytes, and type Unicode is Unicode. That makes no sense at all, so let's take a look at some code and see if we can clear that up. Firstly, you have to put this voodoo at the top of your file here on this first box, coding UTF-8. You don't always have to do that, and you don't have to do it in IPython Notebook or Jupyter Notebook generally, but sometimes you need to do it in some editors so you can actually see the Unicode characters printed to the screen. Let's run this box real quick. Okay, so here in this next box, we have a character string, and if we print it out, we get the character string. And if we look at the type, it's going to be typed string. We can also create strings of type Unicode, as we just mentioned. So instead of just writing the string, we can put a little U in front of it, and we get type Unicode. In general, you're going to want to work with strings in Unicode because it'll avoid a lot of unpleasantness and odd errors. In particular, the length of a sequence of characters in Unicode is what you would expect it to be. So in this case, we have the length way at the far right of this A, which we would expect to be 1. And in Unicode it is, but when we look at it just as a regular string, it's actually of length 2. And that's because underneath, it's actually represented as 2 bytes. We're representing something as strings that's actually looking at it as bytes, but generally when we ask for the length, what we want is the characters. This next box covers how sometimes you'll get text from some unknown encoding. So UTF-8 is the most common representation. So what we can do is we can create this function convert Unicode, which is going to convert to Unicode. So it's first going to say if the thing coming in is string, then convert to Unicode by decoding it into Unicode using the representation UTF-8. And if there's any errors, ignore them. I end up using errors ignore a lot when I'm dealing with text from the internet. Often I have a lot of text and I don't care if I miss some of it. If you have a situation where you really need to know every aspect of text that comes in, then you can take off that errors equal ignore and it will flag if it's unable to convert it to Unicode. So going on, the function just says, okay, if it's already in Unicode, just return it. So here we can give it a string, it's type str, but then when we convert it, we get type Unicode, as we see here. Now, one wrinkle is to write to a file, it needs to be encoded back to bytes. In this case, we see the box where we have to encode the text back into bytes so it can be written to a file. Otherwise, we're going to get the Unicode encode error. So we have just a regular Unicode string. We'll see it's type Unicode, and then when we try to write it to a file, we're going to get a nasty error. We have the dreaded Unicode encode error. And what it's saying is it's trying to use ASCII to encode it, but it can't because ASCII doesn't represent that character. So what we have to do is, after we've put everything in the Unicode, to write it to a file, we have to encode it, and we have to say use not ASCII, which is the default in Python 2, but UTF-8, and we're going to ignore errors again. Of course, you can take that off if you want to get every last bit of text, and you want to really know if there was an error. So we started off as Unicode, we encoded it in the string, and we're able to write to a file. So that's Python 2. Now Python 3, arguably the biggest advance is that it has much better string representation. So there's just type string, there's also bytes, but mostly you're just going to work with string, and that is Unicode, oddly enough. So you have string, in this case type is Unicode. So let's look at some Python 3 code right now. So here, top box, we have just a string. We didn't say it was Unicode, but when we print it out, we get type string, which is Unicode in Python 3. If you see in the upper right on this IPython notebook, we're working with Python 3. And we see that in the next box when we ask for the length of this string, and we're going to get 1 because we're representing everything in characters. And we can see that it makes life easier when we write to a file. We don't have to decode, encode, re-encode, and re-decode and all that silliness. We can just write it to a file. That is the worst of Python. The Python 2 to Python 3, the Unicode, the string, it's madness. And we've actually gone through the worst of it now, so everything else in Python is pretty intuitive. And the code in this video will work in both Python 2 or Python 3 unless I specify otherwise.